Greetings everyone, I'm Tiara and this is my partner Callista. We are from SMA Santa Laurencia and today we are going to present our scientific work regarding the potential of ecoenzyme enriched with Lantana montevidensis as mosquito repellent. So the reason we chose this topic is because people can get bitten by Aedes aegypti mosquitoes that can cause dengue fever and can lead to severe complications like damaged blood vessels up until death. People prevent this, especially Indonesians, by using mosquito repellent in the form of lotions. However, commercially sold mosquito repellent lotions usually contain DEET. DEET itself is harmful for our health if we use it for a prolonged period of time and can lead to complications such as seizures, comas, hypertension, up until death. So the problem we are trying to solve is the dengue fever, which is caused by Aedes aegypti mosquitoes, and the DEET in mosquito repellent lotions that are harmful if prolonged exposure. So our objective is to find a substitution to DEET component and to produce a less harmful version of a mosquito repellent lotion. For the methodology, we will first prepare all the materials needed, produce the ecoenzyme, make the lantana plant extract, and later on, we will make the mosquito repellent lotion with concentration 0%, 5%, 10%, 15%, and also 25%. Lastly, we will catch the mosquitoes and do the effectiveness of the lotion testing using our arm. For the ecoenzyme production, we will use a mixture of 5 different fruit peels and combine them with molasses and water and ferment it for 3 months. Later on, we're gonna do the extract production by using lantana plant and putting it into the ecoenzyme and fermenting it for another month. Lastly, we will use the solution and putting it into a strainer until finally all the solids are strained and we were just left with the pure extract. So for the lotion production, there will be 2 phases, water and oil, and we will emulsify it until it becomes a lotion consistency. For the different concentrations, we will use a certain amount of plant extract and substitute the aquades in the lotion. And for the effectiveness testing, we'll use a box full of mosquitoes that we already caught, and we place our hand that is already covered by the lotion with the specific concentration of plant extract and see if there's going to be any mosquitoes that purges or approaches our hand.
In addition to that, we also did the flavonoid and terpenoid examination. For the flavonoid examination, we're using the Harburn method, which is done by mixing the extract with magnesium powder and a few drops of concentrated hydrochloric acid. With this, it could yield a result of a range of colors from yellow to red. If the result shows a yellow in color, that means the extract contains flavonoid compounds. For the terpenoid examination, we're using the Salkowski test, which is done by mixing the extract with some chloroform and then slowly adding a little amount of concentrated sulfuric acid solution. This will create a reaction that could produce 2 different layers, one being transparent and the other being reddish and brown. If the result shows this, that means the extract contains terpenoid compounds. And this is the result of our terpenoid and flavonoid examination. The flavonoid examination shows a mixture that is yellow in color, and the terpenoid examination shows a mixture that's contained in 2 different layers, one being transparent and the other being reddish brown in color. This proves that our extract contains both compounds, flavonoid and terpenoid. The sesquiterpene hydrocarbons belong to a class of terpenoids. Thus, our extract has a possibility of containing these hydrocarbons, and so it is able to make the mosquito repellent lotion more effective, as sesquiterpene hydrocarbons are an active ingredient that helps to repel mosquitoes. And this is the data that we got from the examination process of testing the effectiveness of our lotion. It shows that the lotion containing 15% and 25% extract repels the most mosquitoes, with almost none perching on our hand. This is due to the fact that there could be a high amount of sesquiterpene hydrocarbons, which was extracted from the lantana plant with the aid of ecoenzymes. Based on previous research, fermentation of the ecoenzyme produces hydrolytic enzymes. These enzymes can act as a catalyst that helps that aids in the speed of breaking down of sesquiterpene hydrocarbons within the Lantana montevidensis plant. This graph further shows that barely any mosquitoes perched on our hand during the experiment when we used the lotion containing 15 and 25% extract. It also shows that the lotion containing only 5 and 10% extract are not as effective. Even so, the lotions containing 5 and 10% extract do show results when compared to the lotion that contains no extract at all. So with that said, even in small amounts of concentration, the sesquiterpene hydrocarbons do give an effect, even if it's not highly effective.
The aim of this experiment is to investigate if ecoenzyme enriched with Lantana montevidensis plant is a potential safe mosquito repellent. Lotion enriched with Lantana montevidensis plant is proven to be effective, and it has been concluded that the sesquiterpene hydrocarbons in Lantana montevidensis is the cause of the effectiveness of repelling mosquitoes. Lotion containing extract more than 15% is optimal concentration to repel mosquitoes effectively. Lotions with extract containing 15 and 25% have a higher level of effectiveness, as the number of mosquitoes purging the hand is near zero.